Hello, this video is an MDAnalysis atom selection language. With MDAnalysis you can make both static and dynamic selections. For example, static selection is when you select atoms by their indexes or select atoms of specific residues in your universe. Those selections do not change with time and they remain the same for the whole trajectory. Dynamic selections are the opposite of static selections. They are updated each frame of your trajectory and they depend on some usually geometric criteria. For example, you want to select all the atoms around specific residue in your universe. And those will change based on distance threshold. In this video specifically we focus on simple selections and on boolean operators which you can use to combine them together. Usually I don't work with DNA or RNA, but I have decided to download a protein databank structure of CRISPR-Cas9 complex, which was determined with cryo-electron microscope, and we can look at it directly in the PDB viewer. It is a large complex of 16,000 atoms which contains both Cas9 and the nucleus, CRISPR RNA and the DNA. You can also read the associated article. We start by loading this complex from the legacy PDB file with the respective RCSB PDB identifier. Then we perform selections using the select atoms method, which is available both in universe class and in atom group class. So you can select atoms both in your universe and in your atom group after you have already selected something. Simple selections are based on the keywords which are commonly used by MDAnalysis users. I have already used some of those in my previous videos, like for example protein keyword, which selects all the protein atoms in your universe. Then there is also such keyword for all the atoms belonging to nucleic acids. And you can also select amino acid residue or any residue by name, by number, by belonging to specific protein chain or chain in general of PDB file, and so on. You can find all available keywords in the user guide, which I am currently using. If you are not sure what the name of specific field is in your topologies, you can either check the topologies file directly, or you can access specific field of your universe or atom group instance to look at all possible options of such selection, like I do here with SegID. You may notice that there are two keywords for residue selections based on their index or their num. Difference is that when you select residues by index, you start with 0, how you would access some residue in a list of Python or NumPy array, NumPy Python library, and with the residue number, it is how you would refer to your residue in your article. So it starts with 1. You can select both one residue and multiple residues by specifying start index number and end index number. You can also select residues by their name using the resName keyword, and it can be arginine, cysteine, actual canonical residues, non-canonical residues, including ligands, which are not chemical residues necessarily, but nevertheless we are doing informatics here, not chemist for the most of it. So in my previous videos I have used atom name keyword to select all the C alphas. Here I will use the same keyword to select C atoms of my protein residues. Similarly, you can select atoms by type. Both name and type depend on file format. Name may depend on first field and type will always depend on the first field. Then there is a combined selection of your segment name, residue number, and atom name, which you can use to select with more specificity your particular one atom. Then there are three less popular keywords, namely alt log, insertion code, and multi. Alt logs are usually only defined in structures resolved using X-ray crystallography, which is not the case here. So we are not sure if we have such alternative locations of atoms, and if we are not sure, we can use any or not any operator. Boolean not operator of MDAnalysis is identical to Gromac's not operator, and the any operator is basically a wildcard operator, which is a question mark. So, for example, we can select all the atoms with alt log or all the atoms without alt log. Then there are insertions which our files may or may not contain, and multi-type is specific to TPR file of Gromax, and we won't see anything related to it in this video. Operators are and or not, and also their combination, like or not and not. Using Boolean operators is one way to chain multiple selections into one selection. Another way is to just pass them into select atoms interface one by one with comma, which is ordered selections. After you made selections, you can also manipulate resulting index groups by combining them, looking for their intersection, difference, etc. This is not equivalent to selections, but rather a consequence of atom groups being basically sets of atoms, so you can perform set operations on them. Set operations can also be combined with logical operators in basic structural programming using if, else, clauses, etc. Here I demonstrate set operations on atom groups. How can we check whether they're equivalent or whether one intersects with another, but I will later probably record another video on this topic specifically. And we will write down as separate PDB files our protein, our DNA and RNA separately. Chimera X is especially good for visualization of such large biomolecular complexes. here we have our atom groups merged and separated. Thank you for your time. If you have any questions, you can ask them in the comments to this video or directly to my email, which I will leave in the description to this video. I will also provide you with link to my GitHub repository where this Jupyter notebook and code will be stored, but later I will update it as MDAnalysis tutorial progresses and add additional Jupyter notebooks on some different topics.